All right, now we're moving on to Chapter 4, Section 2, which is Proportions and Similar Figures. So you can title your notes. Before we get started, though, on any problems, I just want to make sure that you're aware of this. A lot of people tend to ignore this part of the problem. First of all, let me tell you what it means. This would read triangle ABC is similar to triangle DEF. So obviously I think all that is common sense, except make sure that you know that this symbol means is similar to. Okay? The reason why that is so important is because sometimes the triangle will be upside down on its side and they won't be corresponding exactly correctly, so you want to make sure that you're matching up the appropriate sides when you're trying to solve these problems. So for this one, it's triangle ABC, so we're going in that order, is similar to triangle DEF. So these are positioned the same way. It means that proportionally they're the same. It's just that one is larger, one is smaller, but proportionally they are equal to each other. So let me show you what I mean. Here they give us 3 of the sides on triangle A, but only one side, on triangle ABC. On triangle DEF, they only give us 1 of the sides. We have to figure out what the value of y is. Therefore, we need to set up a proportion. Many different ways to do this. Let's go through a few. You could set up 20 over 18, but if you do it that way, since we put the 20 on top, you have to be careful when you set up the other ratio that you put the y on top. So that would be y over 12. Or you could set it up, okay, so we're looking at this one in the middle now. This is the same proportion, we just flipped these upside down. So I did 18 over 20, but since I put the 18 on top in the ratio on the left, I have to put the 12 on top on the other one, and that's 12 over y. Another way to do it would be, looking at this one, 20 over y. So we started with the triangle ABC and then we did triangle DEF, but then I need to make sure that I put the 18 on top in the other one so that the triangle ABC is on top in both ratios, so it'd be 18 over 12. You could also flip this one upside down, so it'd be y over 20 equals 12 over 18. Like I said, many ways to do this. You just have to be careful not to put the 20 corresponding to the 12 because those are in no way related. They're not on the same triangle, they're not in corresponding positions, so that would not be correct. Any of these, though, will get you the same answer because as you can see, when you go to cross multiply, you're multiplying 18 times y, 18 times y, 18 times y, and then 20 times 12, 20 times 12, 20 times 12. So all of them will get you the same answer, just different ways of thinking. So I chose 20 over y equals 18 over 12. So just like we did with our proportions, you want to cross multiply. So 20 times 12 equals 18 times y, and then we would solve. So 20 times 12 would be 240. Bring down the 18y. This is multiplication, so we need to divide by 18 on both sides, and you get it's about 13 1/3 is equal to y. And since there were no units in the problem, I don't have to put any units. If it had said inches or feet or centimeters, I would have to make sure to include that in my answer. But that's my answer because there were no units. All right, next problem. It says a tree casts a shadow 7.5 feet long. A woman, 5 feet tall, casts a shadow 3 feet long. How tall is the tree? Okay. This problem, for me at least, would be very difficult unless I visualized it. So I always draw a picture when I get to problems like this. So here's my tree on the right. I know, it's kind of funny. And then here's my woman on the left. So it says a tree casts a shadow 7.5 feet long. What that would mean, a shadow is on the ground. So the shadow would be down here, and the shadow is 7.5 feet. I'm just going to put 7.5. The woman is 5 feet tall, so her height here is 5 feet, and she casts a shadow, I guess it would be shorter than the 7.5, so that would be 3. Now we want to figure out the height of the tree, so we want to figure out this distance right here from the floor, from the ground to the top of the tree. Now I can see that I need to set up a proportion, so like I said before, there's many different ways to do this. I could do the 3 feet over the 7.5 feet because those are in corresponding positions. And then I need to make sure to put the 5 on top because that's the woman over x. Okay, many ways. I actually think I did that one, yep, in this example. So again, you would cross multiply then. So you would have 3 times x. Did I do this on the next one? Yeah. So 3 times x is equal to 7.5 times 5. And you would just solve this. So 7.5 times 5 would be 37.5. This is obviously 3x. And then we need to divide by 3 on both sides. So we get x equals 12.5 feet. So going back to the question, the height of the tree is 12.5 feet tall. All right. Last example here. The scale of a map is 1 inch to 10 miles. Find the actual distance. So if you're looking at a map, not a lot of people are familiar with those anymore because we use our GPSs and every other thing that we have, but if you measure the distance from a certain place on the map, let's say Chicago to Berwyn, and you measured it to be 1 inch, that means that that actual distance in real life is 10 miles. So what they're saying is on the map here, you measured the distance to be 1.75 inches. How many miles is that actually in real life? So set up the proportion. Here I did 1 over 10 is equal to 1.75 over x. Again, many ways to do this. I just chose that way. So you would cross multiply then. So you would have the 1x equals 1 times x, and then that equals 10 times 1.75. So then 10 times 1.75, you guys know the trick, right? Just move the decimal place over 1. So that's 17.5 equals 1x. Now you could divide by 1, but you don't have to because 1x is the same as x. So the answer is just 17.5 miles. So in real life, that would be 17.5 miles from those two places, whatever you measured on the map. All right, that's it for today, guys. Bye-bye.